Hi, we would be discussing solar power and how it is related to the smart grid. First, how do solar panels work? A solar panel produces electricity by converting solar energy from the sun to electrical energy. Solar panels are made up of smaller units called solar cells, and most of these cells are made up of silicon semiconductors. This is a more in-depth picture on how it works. Solar cells contain two different layers of silicon. An N-type silicon has extra electrons and P-type silicon which has extra spaces for electrons, called holes. This creates a positive charge on one side and leaving a negative side on the other. When the light from the sun strikes the silicon cell with enough energy, negative charged electrons gain enough energy to move around. Due to the electric field at the p-n junction, electrons are drawn only to the n side, while the holes are drawn only to the p side. Because electrons are collected in only one direction, direct current is generated. Each solar cell generates about half a volt. From this, connecting two cells in series can produce 4 times the power. These cells can then be stringed together in modules to generate the more voltage and power. And this is how large-scale solar energy industries do, which is connecting the solar panels in several arrays in order to produce enough power for the use of its energy consumers. But how does solar power connect to the grid? They connect to the grid in 4 different steps. First, the solar panels, the solar inverter, switchboard and electricity meter, and the main grid. The first step, solar panels. Obviously, it is the way in which solar power produces energy. When the sun shines on these solar panels, generating DC electricity. And the next step, solar inverter. It converts the DC electricity from the solar panels and converts it to usable 240 volts, 60 hertz AC electricity. Switchboard and electricity meter. With the use of the AC electricity produced, it is then connected to the household, which could be directly used and power up the house. In these times, in times where there are a surplus of power at at the afternoon, powers could be sold to the grid. And while during night, when solar panels do not generate electricity, the grid will then provide energy to the household. And at the fourth step, the main grid, with the excess energy sent to the grid by the solar panels, it distributes it to others who needs the energy. And this is a diagram on how residential solar panels are connected to the grid.
Okay. Then for me, I will be presenting the PV strings design types, the different types of PV systems, how they are connected to the solar power inverter. So there are the node string type, PV systems with DC combiner box, and the direct connection type. So let's discuss each one. So first we have the node string type. In the node string type, all positive terminals of the PV modules are connected to one node as shown here, and while the negative terminals to another node before it gets connected to the solar power inverter. Next is the PV system with DC combiner box. So in this design type, the positive and negative terminals of the PV modules are first connected to a DC combiner box here before it gets connected to the solar power inverter. And the last type is the direct connection, where the positive and negative terminals of the PV modules are directly connected to the solar power inverter. Next, I will be discussing the different kinds of solar charge controllers. But first, what are solar charge controllers? So, solar charge controllers are used to manage the output power of a solar panel. It is used to ensure that the batteries are not overcharged during the day and that power does not run backwards to the solar panels at night. There are two types of solar charge controllers: the pulse width modulation type, or PWM, and the maximum power point tracker, or MPPT, solar charge controller type. Let's discuss each type. First, the pulse width modulation, or PWM. Pulse width modulation, or PWM, solar charge controllers have a direct connection from the solar array to the battery. So from the solar panel, we will connect it to the PWM. Next, the PWM modulates and controls the output of the solar panel to maintain a constant voltage, matching the battery voltage. So if, for example, the solar panel produces about 24 volts of output voltage, the solar charge controller, PWM, pulls it down to 12 volts, matching the capacity of the battery bank shown here. However, this method is inefficient because it pulls the solar panel's voltage below the solar panel's optimum operating voltage. That's why researchers developed before that, let's first discuss how the pulse width modulation PWM works. So from this figure, this shows how the PWM works. And as shown here, it uses a basic rapid switch on, off, on, off, on, off, as shown here, to modulate or control the output voltage. A transistor inside here is used as the switch to rapidly open and close the circuit, reducing the current and thus maintaining a constant battery voltage. So from the inefficiencies brought by the PWM, researchers developed the maximum power point tracker, or MPPT, to increase the efficiency of solar panels. So an MPPT is an efficient DC to DC converter used to maximize the power output of a solar panel. So how does an MPPT work? So first, in order to generate the most power, the maximum power point tracker, or MPPT, sweeps through the panel voltage to find the best combination of voltage versus current to produce the maximum power. So remember that voltage times current is power. So if we look at this graph, so when the MPPT sweeps through the voltage, the point where the maximum voltage is reached is chosen as the reference point. And looking at the current graph, we will see that at this point, this should be the output current. So that means this point here is the maximum power point. So let's compare what's the difference between PWM versus MPPT. In the example below, as shown here, a common 60 cell or 24 volt solar panel with operating voltage of 32 volts is connected to a 12 volt battery bank using both PWM and MPPT charge controllers. So using PWM controller, the panel voltage must drop from 32 volts down to 12 volts, as shown here. and thus an output current of 8 amps. So using the PWM controller, the panel voltage must drop to match the battery voltage, and so the power output is reduced dramatically. On the other hand, on MPPT, we have a MPPT charge controller. The panel can operate at its maximum power point and in turn can generate much more power. As shown here, the current going through the battery is 20.8 amps as compared to 8 amps here in the PWM. So as you can see here, with a 32 volts output of a solar panel in MPPT and at 20.8 amps, there is much power given to the battery as compared to PWM. So we can also see from this graph that the PWM has a 100 watts generated output, while in MPPT charge controller, the output is 250 watts. So that concludes our presentation. I hope you learned today what is solar power. So I am Michael R. Contreras, and my
I
partner
I
here
I
is
am Mikael Jokno.
we are from 5EEC, and goodbye.
Bye-bye. Thank you.
Thank you. Stop recording. Nasaan?